and welcome to this session where we'll be working together to solve one of the most challenging problems at re:Invent, and that is finding your next favorite brew here in Las Vegas. I am Anna, developer advocate at AWS, and I'm joined here today by Jenna Patterson, who's a senior developer advocate at AWS. Here's the agenda to this session. We'll first go over our problem. Where can we find a good beer that matches our tastes and preferences? Then we'll talk about our solution to this problem, a mobile application called Find My Brew. This application uses several AWS services, but we'll be diving deep on the services that provide the two most important features: recommending beers that you will like and showing you the locations where you can find them nearby. We'll give you details on how we built the app, demo its functionality, and show you how we solved user onboarding with a swipe interface. Finally, we'll leave you with some resources that you can check out on your own if you're interested in building something like this. So here's the main problem we are trying to solve. You're in Vegas, walking the streets, and maybe this is your first time here, or you haven't been here in a while. You want to relax and enjoy a nice beer at the end of the day. You walk into a local pub or restaurant, and you are faced with an overwhelming variety of beers to choose from. Wouldn't it be awesome if there was an app that helped you find nearby places where you could get a beer that matched your tastes and preferences? The good news is that we have an app for that. Find My Brew is a responsive, web-based application with a mobile interface that gives you beer recommendations and shows you where to find those beers nearby. It is backed by microservices on AWS, and it uses machine learning algorithms powered by Amazon Personalize to learn your interest in beers and to make recommendations based on those interests. It is also location aware, so we can guide you to nearby places where you'll find beers that you will enjoy. This is the high-level architecture diagram showing the major components of the application. The mobile application loads static assets from a CloudFront distribution backed by an Amazon S3 bucket. Once loaded, the application makes REST API calls to several backend microservices that are running on Amazon Elastic Container Service. We'll focus on two of these microservices. The recommendation service uses Amazon Personalize to provide personalized recommendations for the current user. And the location microservices leverages the Amazon Location Service for location-based functionality. The application also uses the AWS Amplify JavaScript library to stream events to an Amazon Personalized event tracker. This is how Personalize can learn about your interests in real time and adjust your recommendations accordingly. Now, let's take a closer look at how Amazon Personalize works and how we used it in the Find My Brew app. We can start by locating Personalize in the AWS machine learning stack. We describe the stack in layers, where each layer builds on top of the other. In the bottom layer, we have the machine learning frameworks and infrastructure used by experts. Above it, we have the machine learning platform layer, where SageMaker Studio lives. It provides all the tools needed to build, train, and deploy machine learning models. In the AI services layer, we have machine learning-based services that provide purpose-built solutions in the areas of vision, speech, chat, and text. Finally, the solution layer at the top is where you find abstractions for several business and industry use cases, including customer experience, healthcare, and industrial. And this is where Amazon Personalize is located, under personalization to enhance customer experience at the top level solutions layer. Amazon.com is a pioneer in personalization with over 20 years of experience. We have learned that different personalization strategies are needed for different use cases. And machine learning has enabled us to deliver unique experiences to individual customers based on their behavior and preferences rather than generic segments of people. Our goal is to enable other organizations to leverage those learnings and make it easy for them to use machine learning with the data and systems they already have in order to create custom experiences for their users. To get started with Amazon Personalize, you start by providing data about your users and items to the service. There are 3 different data types we use for modeling on Personalize. The first one is the activity of your users, which is also known as events or interactions. Examples might include the items your users are clicking on, browsing, reading, watching, or purchasing. This data set has the strongest signal for our machine learning algorithms and is the only one required by Amazon Personalize. The second data set is item metadata. This includes details about your items, be it your products, movies, beers, whatever you're recommending. These details might include things such as color, price, genre, and category. This is essentially the information you already have on your item catalog. This dataset is optional, but it's really useful for scenarios such as cold start, when you want to make recommendations for new items. The third and final data set is the user metadata. This includes details about your users. It could be their age, location, or their subscription tier within the service. You can import data into Personalize using 2 different methods. You can import your datasets in bulk, or you can stream events, items, and users using 3 different streaming APIs. Then, in just a few clicks, you get a custom personalization module trained and hosted for you by the service, which you can use to retrieve recommendations through a private API. Behind the scenes, Personalize performs all the steps you would typically find in a machine learning pipeline, including processing and inspecting your data, identifying which features are the most important ones, selecting the right algorithms and parameters to train those models, and training and optimizing those models. Finally, it will host them for you behind an auto-scaling API. Now, we are going to show you a quick demo of the Find My Brew app and its recommendation capabilities. When you first start the app, it will ask you to sign in or create an account. We are using Amazon Cognito as the authentication provider for Find My Brew. Since I already have an account, I'll go through the sign-in process, entering my username and password. This is an account that I have already used and went through some interactions with beers that I like, most of them pale ales and lagers. Here we can see the first personalization that is inspired by my beer reviews. I'm getting beer recommendations that match my interests. As we scroll down on this page, we're going to see lagers and pale ales, which are the beers that I have interacted with in the app. If we scroll to the bottom, we have featured beers. These are a list of beers that are marked as featured in the database. We are using personalized ranking algorithms to re-rank the featured beers based on my interests. So over here we see ales, pale ales, and lager towards the front, and we see other beers that don't really match my interest further towards the back of the list. We see a Belgian one over here that I don't really like, and also a couple sour beers, which I'm definitely not a fan of. The app also has a categories menu where we can list beers by a particular category. If I go into the IPAs, I can scroll down and look for beers that I like. For instance, if I had tried the State of Change West Coast IPA last night, I could indicate that I like it by clicking on the thumbs up button to let the app know it. In this moment, Find My Brew is sending an interaction back to Amazon Personalize, indicating that I like this particular beer. That's how Personalize is learning from my interests in real time. Jenna will let you know all about the location functionality that you are seeing here, but I also wanted to highlight the third type of personalization we have at the bottom of the beer page. This is another personalized use case of similar item recommendations. We see similar beers to the one that we're currently looking at based on all other user activity. So I can click in one of these beers, and if I had tried this recently and enjoyed it, I can indicate that I like it. Personalize keeps learning from my interests in real time, and as we go back to the home page, we should continue to see the recommendations change and adjust based on my app activity. So how can you get started with Amazon Personalize? The first step is defining your data sets. As we've seen before, there are three types of data sets we can use: interactions, users, and items. In the Find My Brew app, the items dataset consists of a relatively small number of beers that are offered at brew pubs and bars near the reInvent campus. We also have a collection of 6,000 users that are preloaded into the app. Each of these users has a persona that defines their beer preferences. So we use those personas to generate thousands of interactions that are then used to train our model. An interaction in Find My Brew consists of a specific user liking a specific beer. After we have defined our dataset, the next step is preparing them into CSV files and importing them into the service. Once they have been imported, we can train our models by creating a solution and a solution version. A solution combines your data with an Amazon personalized recipe, which is an algorithm designed for a specific use case. Personalize has a recipe for the three use cases we have seen on our demo. User personalization: when given a user, we're recommending beers that this user could like. Related items, where we provide similar item recommendations based on all user behavior. And this is what we saw on the beer page, where we were showing beers related to the one currently being viewed. And then personalized ranking, which lets you take a list of items and re-rank them based on a specific user's interest. That's what we saw at the bottom of the homepage with the featured beers list. A solution version represents the final train model. Once you have your solution version, you can create a personalized campaign. The campaign provides you with a private API used to retrieve the recommendations. Now let's walk through the AWS console to see the personalized resources that were used for the recommenders on Find My Brew. Here we are in the AWS console for this app, and we can go into the personalized console. From here, we can see that we have a single dataset group. A dataset group is a construct that collects datasets, models, and the campaigns that represent a particular use case. The name of our dataset group is Retail Demo Store, and that's because Find My Brew is built on top of an open source project called Retail Demo Store. Jenna will go into more detail about that later. So going into the dashboard for the dataset group, we see all the steps required to build a recommender system with Personalize. We can start by going into the datasets. Over here, we have one data set for each of the data set types we saw earlier: interactions, users, and items. The interactions dataset maps users interacting with items at a particular point in time. You can also have additional contextual data in your interactions dataset. To import a dataset, you can start a dataset import job. From here, we can see the schema for the dataset defined in JSON. The schema uses the Avro syntax, which is a record definition format commonly used in event-based applications. The required columns for interactions are the item ID, user ID, and timestamp. Over here, we also have an event type column. In Find My Brew, we only have one event type called Product Light. There's an additional metadata column of discount, which is part of the retail demo store, and we're not taking advantage of that in the Find My Brew app. From here, we can give our dataset import job a name and select an IAM role that gives personalized access to your input file inside an S3 bucket. Now let's take a look at the user's dataset. Find My Brew has 6,000 fictitious users, and each of them has user ID, age, and gender. You can have up to 5 metadata fields that are suitable for your use case in your user's dataset file. Finally, we have the items dataset. It provides information about our beers. On the schema for the items, we have an item ID that identifies each beer, and we also have category and style for our beers. So that could be IPA and New England IPAs, or Pale Ale and American Pale Ale. The description is a textual field that describes the beer. Having this textual attribute tells Personalize to apply natural language processing to extract features out of that description and include those in the model. We have 2 specific beer fields here. ABV is the alcohol by volume, which is the level of alcohol in the beer. Since that impacts the style of beers and user states, we thought that would be a good attribute to include in the items dataset. Finally, IBU is the International Bitterness Units, which is an indication of how bitter the beer is. That also has a strong indicator of user preference in beers. IBU can be either null or an integer, and that tells Personalize that not every beer has an IBU value. That way, Personalize will still include beers that do not have an IBU when training our model. With our data sets defined and imported, we can then create an event tracker. An event tracker is an endpoint that allows us to stream interactions into Personalize in real time. Personalize can then learn from them and adjust recommendations. You can integrate the event tracker directly in your application using the JavaScript SDK, which is part of the AWS Amplify library, and it also requires an Amazon Cognito identity pool and user pool. You can also stream events to Personalize server-side. Here's an example showing how you might use Kinesis Stream to capture clickstream events, and then a Lambda function to consume that stream and write those events to the event tracker. With our data sets and event tracker created, we can move forward to actually training models. For the Find My Brew app, we have trained 3 different models, one for each of the core use cases supported by Personalize. Here you can see the different recipes or algorithms we're using. Personalized ranking re-ranks items based on user preference. User personalization makes recommendations based on an individual user. And then AWS SIMS which, given an item, will recommend other similar items. If we click on the product personalization solution, you can see that we have a configuration of the recipe, and also there's room for additional configuration that we can provide. When we train a model in Personalize for a solution, we create what is called a solution version. When creating a solution version, Personalize will provide a collection of offline metrics. These are an indication of how well the model performed against held out data. So how effective the model was at predicting what beers a user would like based on the data we had on the training set. Finally, once you have trained a model, you can create a campaign. A campaign is a private auto-scaling API that allows you to get recommendations out of your trained model. So for the user personalization campaign, we can see that there's an campaign ARN, which is what we use to get recommendations from this campaign. And you can also get recommendations right from the console by putting in an user ID and clicking the Get Recommendations button. Here we can see a list of recommendations for user 12. And based on these item IDs that we have prefixed with the style of each beer, we can tell that this user is interested in dark, heavier stout beers. We can see some imperial stouts, American stouts, a brown ale, an oatmeal stout. That way, we can get a clear sense of what these user interests are based on the recommendations. Other features of Personalize that we are not using in the Find My Brew app include filters, which allow you to build business rules into Personalize to include or exclude items based on rules that you define. And then batch inference jobs that allow you to generate recommendations in bulk that can then be imported into a caching system or an email marketing campaign. Now that we have our recommenders built on Personalize and the recommendation service running on ECS, let's take a closer look at some of the code behind the recommendation side of the application. We'll start with the JavaScript code in the web application that calls the recommendation service. First, we're getting the microservice domain name and port from environment variables, and we're using them to build an URL. Then, we are using the Axios library to create a connection to that URL. We expose the Get Recommendations for User function on line 14 that can be called to get personalized recommendations for a given user. This function makes a GET request to the recommendation service and returns a JSON response to the caller. On the other side of this call, we have the recommendations microservice that receives the Get Recommendations call. This is an application written in Python with the Flask framework. On line 7, we are creating the personalized client used to get recommendations from Personalize. On lines 8 through 9, we are using AWS Systems Manager to retrieve the campaign ARN that identifies the product recommendation campaign we're going to be calling. We then set up the recommendations entry point that was called from the JavaScript code. And on line 12, the Get Recommendations function starts by getting the user ID from the request and then calling Personalize to get recommendations for that user from that campaign. What's not shown here for brevity is the step of decorating the response with details about each of the beers. Personalize provides in its response only a list of beer IDs. Since those aren't useful on their own, we retrieve additional information on each beer from the product's microservice. So we decorate the response with the beer name, ABV, IBU, a link to its image, and its description. Then we return that information to the caller as a JSON array of recommendations. As we've seen on our demo, when a user likes a beer, an event or interaction is streamed back to an Amazon Personalized event tracker. To do this, we are using the AWS Amplify JavaScript library. So this is the code required to configure the Amplify library. On line 3, we are registering the Amazon Personalized Provider with the analytics component of Amplify, but there are also other analytics implementations that Amplify supports, such as Pinpoint and Kinesis. On line 7, we configure Personalize by providing the tracking ID of the event tracker and its AWS region. You can also specify the maximum number of events or delay in milliseconds to wait before flushing events back to Personalize. Once we have the Amplify analytics configured, we can use Amplify to stream events to the Personalized event tracker. The project liked function on line 5 is called to send an event. Inside it, we are calling the record function of the Amplify analytics, including the following payload: the event type, which in Find My Brew is product-like, but you can create your own event types that match your use case. The user ID, in this case, the user that is liking a particular beer. And then we also have other properties that include the item ID, which indicates the beer that the user is liking, and also the discount, which is not being used in this case, but is required in the original schema that the app uses. One of the challenges when building a personalization application is choosing the right metadata. When we started implementing Find My Brew, we looked at the metadata available for beers. We thought that beer style, such as IPA, lager, stout, was an important categorical metadata that would indicate a user's interest. Personalize can use this metadata to identify patterns and learn what a user likes. The description is also very useful unstructured textual data in which Personalize can use natural language processing to extract information that's not usually available in structure fields, such as style. Price can either be important, and including it will allow Personalize to learn how price impacts end users' interest. The two remaining fields are more characteristics of beers. Bitterness helps Personalize learn your pattern of interest as it relates to the bitterness of the beer. And finally, the alcohol percentage also affects the taste of the beer, and including it in the model allows Personalize to learn based on that feature. Context is another interesting area to consider when building recommenders with Personalize. This allows you to specify metadata that is not static to the user or the item, but contextual to the interaction. To take our recommendations on Find My Brew to the next level, we have considered incorporating seasonality, day of the week, weather conditions, or even food pairings. Providing contextual metadata with interactions allows Personalize to learn what beers you like at different times of the year or when the weather is cold or hot, allowing you to make more relevant recommendations. Another common challenge with recommenders based in machine learning is cold starting new user. A cold user is one that the recommender has never seen before, that is, or new users. Since we want to start providing useful recommendations as soon as possible, there are a few ways to approach this. We can start by recommending popular items and then learn what the user likes based on their interaction with those items. This is simple to do with Personalize because it returns by default the popular items for users that it has never seen before. Another approach is to include a checklist or questionnaire during sign-up, or ask new users to rate items as part of their onboarding. If you can map the input from those ratings to interactions, then you can provide that to Personalize, allowing you to learn their interests right from the start. This is exactly what we did with Find My Brew, where we included a swipe interface for new users that sign up to the app. This is something we had a lot of fun building, so let's take a look at the swipe interface in action. When you first bring up the app, you are asked to either sign into an account or create an account. Let's go through the create an account experience so we can see what the swipe experience looks like. I'm gonna enter my username, password, and email. And after that, I'll receive a confirmation code via email. I'll type that in here, and now we can sign into our account. Upon initially signing in, you're presented with a series of cards that you can swipe left or right to, indicating your preference in different styles of beer. This is used to learn what beers you like and send those interactions back to the event tracker. Personalize will then be able to tailor recommendations based on your input as soon as you first enter the app. So we're starting with sour beers, which I'm definitely not a big fan of, so I'm gonna swipe left on those. Now we have IPAs, which are my favorite by far, so I'm gonna swipe right. I don't really like lagers at this time of the year, so I'm swiping left, and the same thing applies for wheat beers. Stouts are really great when the weather is getting colder, so I'm going to swipe right on those. And ciders are definitely a no for me. I don't really like fruiting my beer. Now the application is streaming those beers that I liked back to Personalize. The service is learning my interests and presenting me with beer recommendations inspired by my beer reviews. So here we can see we have a collection of ales towards the top and also a couple stouts here. We have a couple more ales and some more stouts. So the recommendations are definitely resonating with the beers that I swiped left and swiped right to. When we get down to the featured beers, the first beer we see is a stout, which is a beer that I indicated that I like. We can also see some ales, an IPA. So the featured beers list is also resonating with the beers that I indicated that I like when I onboarded the app. This was a great way for us to bootstrap a cold user experience with Personalize and start making meaningful recommendations as soon as possible. Now let's take a look at some of the code used behind the swipe interface. The web application user interface was implemented using Vue.js. So here's the template for the swipe cards you saw in the demo. And we have a card container that holds the swipe cards. It iterates over a collection of beers and creates a swipe card for each beer we want the user to rate. When you swipe left, the onSwipe left function is called, and when you swipe right, the onSwipe right function is called. The code that is triggered when you swipe left is shown on line 2. It removes the beer from the stack of cards and ignores it, since the user doesn't like this particular type of beer. The code that is triggered when you swipe right is shown on line 5. It also removes the beer from the stack of cards, but then it adds it to a list of liked beers. When the user finishes swiping through all the cards, the onCompletion function is called, calling the record liked products function on line 15, which sends a product liked event to Personalize for all the beers that were liked. The user is then redirected to the homepage, where Personalize will be able to provide recommendations that match their preferences. Now, I would like to turn over things to Jenna, who will be talking about the location-based functionality of our app. Thank you.
Thank you, Anna. So now that we have recommended beers in our Find My Brew app based on our interactions, we would like to find out how to get to our next favorite beer. And we wanted to add in the context of location to our app. And we did that using Amazon Location Service. So we needed the ability to pull in maps and to visualize locations on those maps for our locations that these beers are being served. And then we also wanted to pull in routing data so that we could navigate to those locations and show a route on the map to get to your next favorite beer. Amazon Location Service has support for maps. It allows you to add in mapping features to visualize our surroundings, to overlay data like the names and info about those locations, and to draw a route on the map so that you can actually get to those locations. It also has support for pulling in routing, and this is going to pull in routing data, which allows us to draw the route on the map. Amazon Location Service also has support for converting addresses to coordinates and back again, and searching for points of interest on a map using a feature called Places. We haven't implemented any of this in our application yet. It's a future enhancement that we might add once we branch out from Las Vegas. We also have access to tracking and geofencing, but our app doesn't need that, so we didn't use those today. We've integrated the Find My Brew app with maps and routing using the JavaScript SDK. And if we were building a native mobile app, we could also use the iOS SDK or the Android SDK. One of the features that I want to highlight with Amazon Location Service is that it's really easy to access high quality data from our location-based services data partners like Esri and Here. As a developer, I want one API to integrate with so that I can experiment with different data providers. This allows me to change out the data providers, use a different one. Also, it lets me swap out different map styles, and I can do that without having to change any of my code. So I write my code once, and then I can make those changes without having to update it. It also means that I don't have to integrate with any external vendors. I don't have to manage any credentials or API keys in my app. And it also integrates directly with other AWS services. So we know that maps help us create visualizations of location information, and they're really the foundation of location-based service capabilities. Amazon Location Service provides map tiles of different styles sourced from global location data providers, like I mentioned earlier, Esri and Here. And these map tiles, they're trusted by millions of customers worldwide, and they benefit from decades of experience empowering geospatial solutions. This means that we can choose the map style or visualization that we want to use for our application, the one that best suits our needs. So let's take a look at how we've integrated Amazon Location Service into the Find My Brew app. The first thing we'll do is take a look at a demo that shows how locations are plotted on a map directly into the app. In the Find My Brew app, there are two different ways to view beers at locations near you. Since we have limited our results to breweries and bars in Las Vegas, you can view a map of all locations right here on the Locations view. You can click on pins to see more information about a bar or brewery. You can also scroll down in the list here and view a little bit more information, like the list of beers that are served at that bar or brewery. The second way that you can view where a beer is located is by going to one of your recommended beers, scrolling down to the map, and you can see that this beer is located at one location in Las Vegas. And we can click the pop-up and see information about that location. So let's see how we built this map and our list of locations. Before we can write the code, we need to set up a map in Amazon Location Service. So we'll do that by navigating to Amazon Location Service in the AWS console. We will create a map. We'll add a name for that map and a description if we need to. And then we'll select the data provider that we want to use, which in this case is going to be Esri Navigation. And we use this one because this data provider has more detailed information about roads and transit features that we're going to use when we add in routing in just a little bit. When we go to our code, we'll need to import libraries. The first library that we import is the MapLibre GL library. This is a JavaScript library that uses WebGL to render interactive maps. If you're familiar with Mapbox GL, this is an open source fork of the Mapbox GL library. We'll use this to add customized markers and pop-ups to this map, as well as to add controls for navigation and geolocating. Then we'll add auth classes from Amplify, and this will allow us to get the credentials of our user so that we have access to the Amazon Location Service map and route calculator resources that we're going to use. Then we'll use the client location from the AWS SDK. This provides an API for us to interact with the data behind our maps. For instance, it's going to give us an API to call calculate route so that we can calculate our route. Finally, we add in a library, the MapLibre GL Amplify library, and this gives us extra support for creating our map using a function called create map. And then as you see on line 6 here, we've added a div element, and this is the element that we'll attach our map to. And in just a moment, we're going to pass this element into that create map function. Next, we need to create the client location. We'll do this when our Vue component loads. We're going to use the client location in the AWS SDK. We pass it the credentials that we retrieved using Amplify Auth, and then we'll pass in the region that our map is located in. Next, we'll need to initialize the map. We do this using the MapLibre GL Amplify function, create map. And we pass it the container of the element that we created a couple of slides ago, the coordinates to center it on. So in this case, we're hard coding this to our location here in Las Vegas, but we could also pass in current location if we wanted to. And then we add a zoom factor. Next, we need to add locations to our map. And we have a small microservice that we wrote, a locations microservice, that passes us back the list of the 14 locations that we have data for in our application. So for each of these locations coming back from that microservice, we create a marker and a custom pop-up. This pop-up could have information like the name of the location, the phone number, the address. It's also going to have our directions button that allows us to show a route on the map. Once we've created that pop-up and added it to the marker, we add those markers to the map so that it displays the marker on the map. One thing to note here is that this Vue component that we're creating that is for our map is reusable. So in our application, we have the location view, which shows all locations that our beer is served on a map. And then we also have the beer detail, which shows the locations that are specific to where that beer is served. So all this component needs is a list of locations depending on the situation, and then it shows the map appropriately. The next thing we need to do is figure out how to get to our next favorite beer. And we do that by using routing so that we can show the route, the distance, and how long it will take to get there. Here, we're going to take a look at one of our recommended beers. We're going to scroll down and take a look at where this beer is served. In this case, it's served at one location in Las Vegas. We press the directions button. It shows us a route to get there from our current location, which is the blue marker at the bottom of the page, and the red mark to the location of the beer at the red marker at the top of the page. Now, we can also look at a different recommended beer and see where that's located. And this one happens to be in two different locations in Las Vegas, but it's a little bit further away. So when I select the directions button, we can see that this one's about 4.5 hours walking, but that's a little bit too far for me. So I'm going to change it to driving mode. And we can see that it's about 19 minutes to drive there. We can also see that the route has changed a little bit. So for walking mode, it's going to choose directions that are, or a route that is based off of where we would walk. So it's going to be more like city streets. Versus if we were driving, it's choosing a route that is more appropriate for driving mode. So highways, freeways, that type of thing. All this information, the toggling back and forth between the different modes of transportation, the current location and our selected location, all of this feeds into the calculate route that we're going to look at in just a moment. So let's take a look at what we need to do to update our code. The first thing we'll need to do is create a route calculator. In Amazon Location Service, we go to the Create Route Calculator page. We're going to give it a name for our route calculator, and then we're going to choose a data provider again. This data provider is the same as the one we used when we created our map, so we're using Esri again. And after we've created our route calculator, we can update our code. So we'll import one library in this case. We're using the Turf JavaScript library. This is an open source library that performs geospatial tasks on GeoJSON data, which we'll take a look at in just a moment. Next, we'll need to update our map initialization. When the map loads in the DOM, we need to add a new GeoJSON source. And this GeoJSON source is eventually going to contain the route features or the parts of the route that we need to show on the map. Then we add a layer, which allows us to actually show the line for the route on the map. Next, we're going to write a function to calculate the route. So on line 11 here, this is calling the Calculate Route API from the AWS SDK. And it takes in some parameters, and it needs to know the name of the route calculator. It needs to know our departure position, which is our current location. It needs to know our destination position, which is our selected location of where we want to find our recommended beer. And then we also set the include leg geometry flag to true. Now, what this is going to do is when we call this API calculate route, it is going to return some extra data to us that allows us to draw the route. It includes the leg geometry, which is the information about the route. And then finally, we add our distance unit of miles, since we're in the United States today, and a travel mode. We're using a variable here. It defaults to walking, but anytime you toggle from walking to driving or back again, it calls this calculate route function and recalculates everything and redraws the route on the map. Next, we need to collect the route features. And what this does is we're writing a function here to translate the data that comes back from the calculate route API call, and we're translating it into the correct format of GeoJSON data using the Turf library. And then finally, we're going to take that data from the make leg features function, and we're going to set that route data on our GeoJSON object for the features array. Next, we're going to set that GeoJSON object on the GeoJSON source on our map, and that is the step that draws the route on the map. All of this logic from the calculate route function all the way down to here is what gets hooked up to our directions button. So when you press the button, or even when you toggle between walking and driving, it recalculates the route and redraws the route on the map. Now, one of the challenges that we encountered during the building of the Find My Brew app is we really wanted to include geo-aware recommendations. So I wanted to be able to say, show me all the beers that have been recommended to me based on my interest and their distance from me. But the challenge here is that Amazon Personalize doesn't use distance as a weighting for recommendations. It doesn't use something like latitude or longitude, which is what we're working with related to distance. Instead, it uses more like a category, so a city or a metro code. This would allow me to ask, what beers do people in the San Francisco Bay Area drink? Or if I combine that with weather or season, it would allow me to ask, what beers do people in the San Francisco Bay Area drink in the summertime or when it's warm out? But if we really did want to make our recommendations geo-aware, we could use a geospatial search to find all the beers nearby us and then use Personalize to re-rank those recommendations that are nearby based on our interest. So now that we have a fully functioning Find My Brew app that shows us our recommended beers, it shows us the locations these beers are served at in Las Vegas, and it allows us to drill into a specific beer and look at the locations that specific beer is served. And we can find our way there using routing. Let's take a look at how we got to this app today and the history behind it. The retail demo store, as Anna mentioned earlier, is a sample web application and workshop in the retail space. So this sample app demonstrates how AWS infrastructure and services can be used to build applications like the Find My Brew app that we showed you today. We used Retail Demo Store as a foundation for the Find My Brew app. This sample app is a collection of microservices hosted in Amazon Elastic Container Service using Fargate. And these microservices represent core domain constructs like products, carts, recommendations, users, and in our case, location, beers, stuff like that. And there are also several managed services that are used here as well. Some of those that we talked about today are Amazon Personalize and Amazon Location Service. And then a few others that we didn't cover today, like Amazon Cognito, Amazon Pinpoint, and Amazon Open Search Service. For this sample app, the user interface is a Vue.js app that is built with support from the AWS Amplify SDK, and it's used to integrate with some of the managed services that we talked about. This app is served by Amazon CloudFront and Amazon S3. We've also used AWS Code Pipeline to support our build and deployment processes. This sample app is hosted on the AWS samples org on GitHub. The name of the repository is Retail Demo Store, and it's maintained by the retail team and a group of solution architects. You can head over there today and press a button and provision all these resources to run this app in your AWS account and play around with all of what we've talked about today and more based on the Retail Demo Store itself. Then I also encourage you to take a look at, there are 4 different reInvent talks here that you can find either in person or on demand for Amazon Personalize or that cover Amazon Location Service. And again, here's a link to the Retail Demo Store that you could check out as well. I also want to thank everyone from the Find My Brew team that made this talk possible. Clockwise from left is myself, Jenna Pedersen, Cosbag, Anna Cunha, James Jory, Chris Howard, and Toby Rigby. And finally, thank you all for joining us today. You can find and follow Anna and me on social media if you have any follow-up questions.